But what we're going to start with here, I'm going to sort of break this up into three different little sections. The first one is not so much tidying it up as just sort of keeping track of things. The second part we're going to do, I'm going to call it ugly parameters. And the last part we're going to call chatterbox functions, which is actually a terminology used by programmers as a chatterbox function and why they are bad. Okay, so we're going to write a chatterbox function, then we're going to write the same function and fix it.
Please excuse all soccer players at this time.
They didn't specify for the what team, right? So it just if you play soccer, you're a soccer player. Yeah, there we go. All right, guys. So part one, guys, we're going to call this local versus global variables. Okay, and we'll go over sort of how this works here. I've already mentioned this before, but I wanted to get it sort of formalized in what we were doing here. Okay. All right. So we're going to make some really simple math functions here. These you really wouldn't need to do. We're just making them for the purpose of, being able to express, a function and a bad version of one versus a good version of one, okay? So we're going to start off with a definition. We're going to define a function called adder, okay? And adder is going to, guess what it's going to do? It's going to like add stuff together, okay? I'm going to make this adder have only one variable. In this case, we'll just call that variable x, okay, or one parameter. And to define my adder here, what's going to happen? I'm going to say y equals x plus x. So whatever parameter we put in, it's just going to take that parameter and add it to itself, okay? And that's all. That's all it's going to do. But what I want to make sure we get in here is I'm going to put a little hashtag in here that y is a local variable, okay? What that means is that y will not be available outside of the function, okay? So if I want to call something y or refer back to that y, I'm really not going to be able to do so, okay? Now, I want to get that information out of there, though. Okay, and I need it to actually tell me what that would be. So I'm going to go ahead and use that return again. I'm going to say return y. All right. Now, if I run this program at this point, nothing is going to happen, right? Because I haven't called that function. Okay. A lot of people early on in programming, they will call that function and then they'll just want to sort of, see what happens, right? So if I say adder and then I put in parameter 5, what should happen is it should call that function, right, and then do 5 plus 5, and what is y going to equal? Well, should y should equal 10, okay? And we can do that, right? And I can go ahead and run it, and we see nothing occurs, right? Well, something did occur. It's just I haven't provided it any way to let you know something has occurred, right? The most common mistake that is made at this point is people say, okay, well, I put my 5 in there, we got our action, so let's go ahead and print y, okay, and run that because y is my answer, and instead we immediately get the error. Now that should be nothing new. I've showed you that already, okay? It's yeah, I even returned y though, right? So it should be like, wait, we know what it is, but that's really not the way it works. If I really want to see what that y is, I actually have to call in my adder. So I'm going to say adder 5, okay? Notice I'm using this as a print function. I can't call y directly because it's just a local variable, but I can call my function adder with parameter 5, and it will give me that return value, so whatever it ends up being. So if I run it now, I no longer have the error and I have a 10, okay? So that's just something important that I wanted you guys to know. Now, if I would like to work with that, yeah. Okay. Okay. Well, I would move to this one on the corner because I know she's not had any problems with it. Really? Oh. Well, that's odd. Did you search for it? Huh. Okay. That's a Seth thing. I don't know how to answer that. All right. So that's one way we can mess with things here. Okay. All right. So what I'm gonna do is I'm gonna just come back here. I'm gonna hashtag that what we had originally put in there, print y, because I want to make sure we understand what's going on here. I am gonna put another hashtag over here. I'm gonna say cannot retrieve y local, okay, outside of the function. Okay. All right. Here I'm going to say print adder5. I'm going to put another little comment. We're going to put a lot of comments on this first one here. Okay. This we can do only because of the return y. Okay. This wouldn't work if I just said print adder5 and I didn't have that return value in. Okay. In fact, I can run it again. See that I get the answer. Take out my return y. You guys don't have to do this and try to run it again. And my answer it gives me back is none. That's always going to be your answer if you don't use return. The answer is always going to be none. Okay, so I'm going to put that back in there to make my function work properly. Okay, return y. Okay, so there's that. Now, I might want to be able to use this more frequently than just calling adder5. Okay, still not? Yeah, that's what you're gonna have to do. We'll have to. I mean, you'll be able to get a copy of it. Okay. All right. So anyway, if I want to be able to use this outside of the function, I can do some other things too. Okay. So I'm going to set a new variable here, z. Okay. And I'm going to say z equals adder5. Okay. Adder parameter 5. All right. Now, when I've done this, guys, over here, when I'm tabbed, when I'm not tabbed in, when I'm over on the left, no indentation. All right. At this point, z, shouldn't use the uppercase there. Z is a global variable. Okay. So Z can be accessed by anything at that point. Okay. That's what it means by global. Any function I write, if I want to include Z in there, I can do that. It's accessible now. If you're using an older version of Python, guys, one of the 2 point somethings, it doesn't assume that that's a global value. You actually have to type in the word global ahead of any value you want global. So there is a little bit of difference there. Since this is Python 3, we don't actually have to do that. Okay, now I can do something like this. I can say, hey, print z. Okay, note I tried to print y up there, and that doesn't work. And now if I run that, I can print z. So notice down here in my shell, it read through the first time, it printed adder5. I said z equals adder5, and now print z, and we can do that. It's right there, 10. Okay? All right, so I can print z now because this is a local variable. Okay. Now, a nice thing I can do once I've got this z in there and I've actually assigned it to, in this case, adder5, I can now start playing around. I can actually add z as my parameter. Okay? So I can do this. Watch this. I can say z equals adder z. Okay. Now, what is z right now, guys? When I printed z, it is 10, right? Okay. In fact, I'm going to go back up here and put that in here. At the moment, z is assigned 10. Okay. What's going to happen now, guys? Now I've said z equals adder z. What's going to happen? It should add 10 plus 10, correct? In this case, it should add 10 plus 10. So let's go ahead and then after that, say print z and see if that works. There it is. There it is right there. It does it. There's the 20. It did it. And I can do that again and again. So what I'm going to just put out here off to the side is that now z equals 20, right? Which is the same thing as 10 plus 10. All right. And that's what I've got. My z is 20. Now I can mess around with this variable in other ways as well if I want to. I could actually set it to z adder z once again. And now if I print z, I should have 40, right? Yep, there it is. Now notice 10, 10, 20, 40. So it's one of the important things, again, about returning that value y and turning it into a global is now I've got more flexibility with what I do with that global. I can even do things like this. I can say print z, whoops, plus 83. I don't know, some number if I want to. Okay? And I can run that, and now I get 123, which is good because z now equals 40, right? So you can play around with this sort of thing if you want to. You can build some loops around it, see what you can do. But really what I wanted to show is that I can't use that y. I have to return it. I can set my z to the adder with um, some parameter there, and then I can start using z, a global variable, for my parameter from there. Okay. This takes a bit of trial and error before you really sort of get the hang of it. Okay, guys. So if you're struggling with these, let me know if you're having like a traceback error or something, because a lot of times it's just sort of losing track of what parameter can do what. Interestingly, like you can throw global parameters into your functions, but it doesn't change the global parameter. So for example, if I have a global x and a local x, when I throw my global x into my function, it becomes a local x at that point, and so it can't actually feed back into my global, so my global doesn't change, and that causes a lot of people problems as well. I just recommend always naming everything a little bit differently so you can keep track of those things. Okay, let's do part 2. All right, part 2, ugly parameters. Okay. Ugly parameter. Yeah, I'm going to come back here. I'm going to put a little space in here. So I'm going to do my little print double quotations just to make a little space between my sort of sections when we run it in the shell over here. All right, so ugly parameters. We're going to make a function. I'm going to define something called bad subtract. All right, I'm calling it bad because I want you guys to understand that this works, but it's not the way we're going to go. Okay. So I'm defining this function called bad subtract, and I'm just going to put one parameter in there. Okay. And it's going to work like this. Variable c is going to be assigned to a minus b. Okay. And then I'm going to say return c. So I can pull that information out of there. Okay. All right. Now notice I've got only one parameter. Okay. So I'm going to, whatever I put in for a, I'm going to subtract b from that. So if I put in 10 for a as my parameter, it's going to be 10 minus b. All right. Now this is just something that people have a tendency to do. And it's a common mistake, which is why we're going over it. So I'm going to set now b equal to a global parameter out here. So I'm going to say b equals 2. So in this function, as long as I'm playing around here, b equals 2. So I can change it from here. Okay, now I'm going to say that the answer to this is bad subtract 8. Okay, bad subtract 8. I always leave the r's out, so I got to see how we're doing. All right. So what this means then, right, is basically its program's going to read this b. It's going to set variable b to 2. It's going to set variable answer to bad subtract 8, which is going to call that definition. So it's going to replace a with 8. And so it's going to say c equals a minus, in this case, b, which is 2. So the answer to c is 6, right? And it can run that. By the way, there's nothing wrong with that, okay? So what I'm going to do now is I'm going to print the answer. Okay, go ahead and run this program. There it is. There's my answer, 6. Move that up a bit for you guys so you can see it. Okay, so there it is. I've got my 6 right there, which is exactly the way things went. Okay, now if I want to change this, guys, and I say, oh, I want to, call that function again with different parameters, I can say, hey, let's set b equal to something else. B equals 4. Okay, I can reset my answer to bad subtract, and I'm going to use 8 again just for, and I messed something up here. There it is. All right, and now I'm going to print the answer once again. Print answer, and I can run that, and it works. Okay, so there we go, right? Everything is hunky-dory. 8 minus 2 is 6, great. 8 minus 4 is 4. All right, so this function totally works, but I called it bad subtract. What's bad about it, guys? Is there a way I could make this just way easier and better? Well, how? Yeah, exactly right. That's just it. Make B a parameter. Now, that may sound really silly, but this is an incredibly common mistake where people will just sort of start putting in variables instead of them being parameters, okay? So we can rewrite that, and I'll show you that it really makes it a lot more sense. So I'm going to put a little space in here and just to make things. All right. So now we're going to do the better option. Okay. So I'm now going to make this good subtract. What's that? My names are wrong? Oh yeah, they're on point. All right, now I'm going to put A and B as my parameters in there. I can make everything else on the inside exactly the same. C equals A minus B, right? And return C. Okay. Now I can't use answer as a variable here, so I'm going to call it result this time because I'm already using answer as a global variable. So I'm going to say result equals good subtract. And now I can put in my parameters. I'm going to use the same ones as I used up above, 8 and 2, whereas I actually set that 2 as a global parameter last time. I don't want to do that this time. Okay, and I'm going to print the result, print result, and then I'm going to do the other one too. Now I'm going to say the result is equal to good subtract 8 and 4, which is what I used last time as well. I'm going to print the result and run my program. Comes up with the exact same answers. Okay, comes up with the exact same answer, but that's what we actually want in this case. It's much better to keep those variables local as much as possible. Okay, and if you need to make them global, you can always do that, like I did here with result. Okay, but up here, what I was doing is I was establishing B as global variables, and they're variables so they can change over time, but I was having to reestablish that each time I wanted B to be something different, as opposed to just typing in parameters. When I type in just the parameters here, B is local only, and so I don't get a bunch of garbled information or retained information in the computer that's really unnecessary. Okay, so this is the more parsimonious way to do it. Hopefully what you guys are finding as you are learning more of these tricks and as you're learning more types of code like our functions and our loops and stuff, you're realizing that you can make programs that were taking you, like in some cases, 50, 60 lines of code, you're being able to shrink those down to 10 or 12 lines of code. And that's parsimony, okay? All right, last thing, guys, we want to look at is part 3, and these are the chatterbox functions. All right. And we're actually already guilty of doing one of these. I actually did it for clarity at the time, but it's not something I would want to do over and over again. Okay. I'm going to add a space in here as well. All right. So a chatterbox function, guys, is a function that has a print command in it or a print function within it. Okay. Problem with chatterbox functions is if you've got a print function inside your function, it's going to print something off every time you call that function. And that can be a real pain. Okay, and that's what we call chatterbox functions. So I'm going to define one here for you. We're going to call this one the cuber. Okay, and I'm going to give it variable x or parameter x. Okay, and what the cuber is going to do is going to take any number I put in there for x and it's going to cube it. So we're going to say x star star or asterisk asterisk 3. Okay, and I'm going to make the chatterbox variety here. So what I'm going to do is I'm going to say print x, okay, comma, quotations, cubed is in quotes, comma, y, okay, and off to the side here. All right, function provides feedback each time it's called. Okay. And that is bad. So I'm going to put that in there too. That is a bad thing to do. Don't do that. Okay. The reason they call that a chatterbox is because it's noisy. Every time you call that function, you're getting some output, right, that the user can see on the screen. And functions are really kind of behind the scenes. You shouldn't be aware that it's running a function, right? It's too much information for the user in this case. All right. And then what I'm going to do is, because I want to get that information back out of there, I'm going to say return y. Okay. Notice, guys, that I'm using x and y, or a's and b's and stuff, over and over again. And that's really not a problem because they're in a function, they're local. Okay? So it actually is totally fine to do that. Notice over here, I used answer one time and I used result the other time. And that's because those are global parameters. And if I keep using answer, it's going to get confused because I already have answer assigned up here. Okay? All right, so there's my cuber. All right, so now I can just do something like this. I can just start calling this function. What's 2 cubed? So I'm going to write cuber 2, cuber 3, cuber 4. All right, so I can do that. Run that, and look what prints out. There it is. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. All right, that's very chatty, right? Every time I run it, it's going to do that. I can do it again. Cuber 5. All right. All right, so it can play around with that. All right, so that's something that is kind of annoying, especially this, guys. What if I want to assign a variable to that? If I say cube equals cuber 5, for example, and then I print cube, I can do that if I want to because I use the return, but it's still very chatterboxy. It now says 5 cubed is 125, 5 cubed is 125, because I call that function again here, right? I would like for that to be silent as it was in the ones we used up above, but this time, because I got that print function, anytime that's called, the computer's going to print it out. So now I've got this redundancy in there as well. I called it here, I called it here, so it prints out twice, and then I set a global variable cube to whatever that was, and then I printed that out. It just gives me 125. But that's a chatterbox function. That's very noisy. So let's take a look at what the better option would be, especially if we want to print something out, okay? So let's go hashtag the better option. This time I'm not going to use cuber because I've already done that, so I'm going to call it squared, and I'll use x again, which is fine. Okay, so this one I'm going to say y equals x asterisk asterisk 2 to square it and return y. Much tidier function. I don't have a big print thing stuff right there in the middle of it, right? And now I can call that function, what's 2 squared, right? What's 4 squared? And if I run the program, I don't see it. Oh, I got a traceback. Oh, it's because it's called squared, not square. Squared, squared. There we go. Now if I run it, yeah, there's no problem. I don't actually even see anything unless I specifically want to see it, okay? So I'm going to make a global variable square, and I'm going to say that is equal to squared, and I'm going to put the parameter 6 in there. And now I can put a print function if I feel like it. I'm going to say, in this case, 6 squared is in quotes, and now I can just type in the variable square if I want to. I can run it like that. And now it gives me the information, only the information I requested be printed. 6 squared is 36, okay? By the way, I was just going to show you one other thing too. If I don't even want to assign a global variable, I don't have to. I can do this. I can say print, let's use another number. How about 8 squared? 8 squared is, comma, and I can actually do this. I can call my function inside the print command, squared 8, okay? Notice I had to do a double parenthesis at the end there. And I can call that and run it, and it works. See? There you go. I can actually do that as well. It's not a problem. Again, I can only do that because I have that return y in there. So lots of different ways to do those things. This is definitely the better option in this case.